My name is Dr. Michael Evans. I'm a planetary scientist at Johnson Space Center, and I'm presenting today on the Gandalf Staff, a mobile science platform for lunar exploration. We are a team of NASA scientists that are working to develop a capability for a self-powered tool on the lunar surface to support both EVA traverses and a standalone platform. I have two PIs working with me, Dr. Michael Zanetti at Marshall Space Flight Center and Cody Kelly at Goddard. My contractors are T-Star and College Station and Jacobs Engineering at Johnson Space Center. And our innovative concept for this project is using Capstone engineering students at Texas A&M to help us rapidly develop capabilities for systems that we're evolving. This is the overall concept of the staff. It's a self-powered tool. It can hang multiple electronics on it for EVA support. It can support a LiDAR and lighting and camera system to illuminate the traverse and to help with sample identification and curation. As a standalone platform, it can be mounted onto a tripod and left, connected to a power source, the solar array, and used for long duration science to collect environmental data on the lunar surface. In our first year, we developed a mechanical prototype just to prove its concept. In fiscal year 21, we received funding through our Center Information Funding IRAD grant, and we developed the power, comm system, data system, our first user interface using a tablet on the staff, a LiDAR to do 3D point cloud mapping, and a lighting system using LEDs. In our second year, we're evolving the power concept to add the power system with a solar array and external battery, creating a rapid replacement battery pack. We're developing a science experiment, which is very exciting, to give us a geothermal sensor probe that can measure temperature gradient in the subsurface. The lighting system is evolving, and we are adding a new capability for EVA support called LunaSAR, which is a search and rescue beacon for the crew that will send an emergency beacon to an orbiting satellite system around the moon that provides biometrics and position for any crewman on the surface. This was our first concept in the first year, where we had the mechanical prototype demonstrating it can be used to support EVA with a crewman and as a standalone platform. These are the teams that were funded in fiscal year 21 to help us develop the initial power system, comm system, that was Hypertech. Our LiDAR system was a team called LOST. Our lighting system was a team called Ether. And then in fiscal year 22, we're supporting the science team with a team called Talos and a power distribution team for the solar array and the rapid battery replacement. This is our LiDAR. The LiDAR generates a point cloud, which can be coupled with imagery from a camera to do very detailed photogrammetry, which is exciting for surface mapping, and it helps our traverse planners and our lunar curation team understand exactly the position and orientation of all samples. This is our lighting concept. This is developed by my team member, Dr. Jack Bacon. We have cars with 40 LED bulbs on them that are mounted around the top of the staff that provide illumination both downward to help with sample identification and collection, and outward for situational awareness. And this system is continuously evolving. This is our tripod system, which was developed by Jacobs Engineering, which provides us with a very stable base. The staff can be mounted into the base and left hands free, so the crew can go off and work with it while the staff is providing illumination, or the base can be left unattended for long periods of time as a science platform. So with the following videos, we're going to demonstrate the capabilities of what we're doing in fiscal year 22. And we are very excited about getting into the field this year and hopefully being able to demonstrate our capability so that we can have a staff that's weighted both for the lunar surface with 1/6G and a staff with the electronics that we can take to the rock yard and demonstrate the systems. Thank you very much.
Howdy, my name is Matt Leonard. I'm the president and CEO of Texas Space Technology Applications and Research. As Dr. Evans indicated, we're the partner with NASA, interface with Texas A&M students in what we call a public-private academic partnership. I'm going to discuss a little bit about that partnership and then talk more about some projects that we're currently doing with NASA, including Gandalf Staff that we're working on with Dr. Evans. In this public partnership, NASA has the role of establishing the technology need and the general requirements. They do this up front so that T-Star has the ability to then select a Capstone team and to manage the projects. We work day to day with the Capstone teams as they are understanding what a requirement is, how to make a performance specification, and then build the right project documentation to go along with the project. So the student teams develop a project management plan. Once they've developed those project management plans, they have to design and develop a working prototype. This includes everything from problem statement, then a concept of operations, defining their functional requirements, understanding their performance specifications, turning that into a test matrix, and then having the ability to develop a working prototype from that. The student teams test, document, and deliver a working prototype. That means that they have to do all of the testing and they document all of that. And they have to do all of the documentation that goes with creating that working prototype so that we have the capability to reproduce that. The T-STAR team provides continued technical development and subsystem integration for the teams. Dr. Morgan and myself are constantly available to the students, helping them mature their design from the concept all the way through the working prototype. Then we ask NASA to demonstrate and evaluate the prototype. They do that in analogous environments to the lunar surface or whatever environment the device is going to be used in. An example of when we've done this before is with Dr. Mark Fries, where we built a cosmic dust collector, or CODICO. In CODICO, we had a very interesting time with our student teams where we created competitive teams and collaborative teams, much like the real world. The students had to work with other teams so that their subsystem could provide Dr. Fries's needs. The SpaceAgs and Icarus teams did the motor control subsystem. They made it to where the cosmic dust collector could spin, and the dust buster, CAMPS, and Cirrus came up with the dust collection, the rotating arm subsystem, the actual dust collection mechanisms. These mechanisms, once they were developed, will be deployed to 100,000 feet where they'll spin and collect micrometeoroids so Dr. Fries can do more analysis of how where those micrometeoroids came from and the makeup of the solar system. Another example of our public-private academic project is Dr. Evans's Gandalf Staff. This is an overall view of the Gandalf Staff and most of the subsystems that we've integrated into it. This is a closer view of the Gandalf Staff and some of the subsystems that we have with it. As you can see here, Lost Solutions was one of our first teams. They developed a graphical user interface that we can use to control all the subsystems on the Gandalf Staff, as well as the LiDAR that gives the photogrammetry that Dr. Evans mentioned earlier. Hypertech was responsible for building a communications capability. This is a UHF voice communications capability, as well as a wireless communications capability. Gandalf Staff has the ability as a wireless access point to communicate back to a base station over the wireless network that Gandalf Staff establishes. Hypertech also developed the power capability for Gandalf Staff so that we can power all of the subsystems that are on the staff. Ether's our next team, and they have developed the lighting capability that Dr. Evans mentioned and the 360-degree camera. And finally, we've got Ad Infinitum. Ad Infinitum is a team that's developing a removable battery pack for the bottom of Gandalf Staff so that we can remove and replace the batteries during an EVA so that the Gandalf Staff can stay on EVA longer. And finally, the electronics package. This started out as a single electronics package for Lost and Hypertech, but as we've had to develop more subsystems, T-STAR has taken over the integration of the electronics package, which allows distribution of the signals that are necessary and the power that's necessary to all of the Gandalf Staff subsystems. We also have another team, Talos, that's developing a geothermal science package. This is a set of probes that will be deployed in the lunar surface that will do measurement of the geothermal properties of lunar material at a distance of up to 70 centimeters. Finally, we've added the ability to do a recharge capability with a power station that's developed by Maverick Technologies. This power station collects solar energy and stores that in a battery system that we're developing, and then allows us to distribute that to the science packages, the Gandalf Staff, and other Gandalf Staff subsystems that need that capability. So overall, these are the capabilities that we're delivering to Dr. Evans for Gandalf Staff at this point. with many others on the way. We're excited about the opportunity to do this and the ability to have this public-private academic partnership that's helping NASA further their efforts in exploration. Thank you.